Hi guys, it's me UBprogrammer and welcome to the lecture 2 of operating system series. And in this lecture we will discuss the types of different operating system. And the first type is single user OS, which will, as the name suggests, only one single user and no other users can be created for this one. So this is obviously you can say small scale OS or uh, really old one right, and a single user use computer at a time, so no multi-time sharing and things like that can be done by this OS. And DOS is that you can say the operating system of this type, right? Then we got the batch OS, and this is the OS which can be used to execute similar type of program one by one by grouping them in a batch. So you want to execute some programs. Let me just grab a pen. So you want to execute in the batch OS program type A, uh, then program type B, then C, then again A, then D, then C. So what it will do, it will just grab these programs which is of category A, and then it will just align it at the first of execution priority, right? And then it will make a group of these C programs because they are also of the same type, and then it will make a batch of that, and then B and D because they are a lone pair, right? So that's what the batch here means. So it will create a batch for similar type of jobs or program. And here I want to mention a job or a process or a program is the same thing referred in the OS course. So these are all the executable programs. So whenever I say job or process or a program, it means the same thing almost, right? Then we got single batch, and then we have multi-programmed OS. Let's see what it does. So multiple programs are executed concurrently, a little by little. So in this batch OS, what the OS will do is it will take these A and A, create a batch, right? So I have said that it will execute these A's properly, like from start to finish. Then it will be free from the A, then it will start the execution of C's, right? And from start to finish, then B and D, right? But in the multi-programmed OS, we are creating batch, right? From the for the same process or same programs, same jobs, right? But we are executing them concurrently or simultaneously at the same time, right? A little by little. So some portion of A will be executed in that very same second. The some portion of C will be also executed, right? Okay, so that's what being said here in this line. And multi-programmed OS are more efficient than batch OS. Obviously we have seen the difference, right? Because it keep CPU busy all the time, and when a process is using IO device, so this is input output device, your keyboard, your printer, mouse and stuff, then CPU will be allocated to some other process till first process again needs CPU. So let me just elaborate this part. So you are this is our process and you are executing, right? only the obviously the OS is executing, and here we have the CPU, and then we have IO. So IO and CPU, and you got the same type of program. So this is P1, P2, or other type, it doesn't matter, right? So you are executing it, and again the IO and CPU. So when this CPU will be allocated to P1, and the P1 wants to do some stuff with the IO, here when it will reach the at the this state, CPU will be free, right? Because it want to do some stuff with the IO device, maybe some printer or other stuff. CPU will allocate it the very next moment to this P2, right? So it keeps busy all the time. That's what we was referring here, right? And again the CPU is like went there. He sees that I don't need it by the P1, so I should go to P2, right? So CPU is busy, and IO devices are also being busy in the multi-programmed OS. So that was the three broad types. Now let's see the next. Okay, and these notes can be downloaded from the description. You can check it out, there will be a link there, right? Okay, and the concept is being introduced here called throughput. So when more processes are executed in less time, so more programs can be done in less amount of time, we say throughput of OS increases. So you can say the throughput of multi-programmed OS is larger than the throughput of multi batch OS, right? Okay, let's take there. And we have the fourth type. So we have studied three. This is the fourth type of OS, which is time sharing OS. So it allows multiple users and multiple process to execute at the same time. So we have multiple users which can use same applications or different applications at the same time in the OS, right? This is the modern OS. And we have the fifth type, which is real-time OS. So it is the OS which will give you the instantaneous result. So you give input, you get output in the exact same time. And obviously the applications are in the medical sector, like the computers or the digital devices in the ICU room, right? Which will give you the heart rate and stuff like that. So it has to be instantaneous, otherwise it will be of no use, right? Okay, so that was the five types of the OS. And let's see the interrupts, traps, and signal. These are the new concepts for you guys. And interrupt is an event generated by a IO device to get attention of the CPU. So that's really simple, right? And so you want to print something, so a printer will create an event which will like he will say his CPU user want to print something, so arrange something for the printing, right? And the trap, it is the event generated by the CPU during execution of the program with error. So if you are writing a program in Python or C++ and your program got error, so it will so the OS will create a trap with the help of CPU, right? And it will say that some part of OS will be executed if we encounter the error in the program. So that's what the trap means. And the signal, it is the event given to the process to do something. So when an interrupt occur, maybe CPU will give some signal to the process or the program being executed at that time, right? Okay, now let's see if we have something left. Yeah, so hardware protection. Now let's see what it says. So this is the concept, as I said, has really a lot of value in the OS course, because the modern OS are time sharing with multiple users and programs, right? The Windows, Linux, they all support multiple users and program to run at the same time. So when many users will use a same computer hardware, so there will be a great chance of the deadlock and other security reasons that a user uh, doesn't want that any other user can see his files. So he want to make sure that his files are only editable or watchable by him, right? So that's what the hardware protection means. And we have in this hardware protection, we have to see this concept first, which is dual mode operation. So CPU can run in two modes, which is user mode and the monitor mode. Monitor mode is controlled by the OS, and it is also called at kernel mode and system mode, and it is controlled by a bit. You can say it when it will be as 0, the program will execute in the user mode, and if something happens, that bit will be changed to the 1 and monitor mode execution will start, right? For example, like when an interrupt or fault occur by a user mode, then CPU switches to the monitor mode, right, the kernel mode. Okay, and IO protection. So what is the IO protection? Is the input output device protection, right? So user mode can only execute the privilege instruction, right? uh, and monitor mode can do the both privilege and non-privilege. So user mode is limited in some sense, so it can't execute every instruction which he wants, right? So when a program in the user mode want to execute privilege instruction, so there will be a note, right? So you got the idea, right? The user want to do something beyond his accessibility or limitation, then the system will be switched towards this kernel mode, and the execution of CPU will be controlled by the kernel mode then, and it will be done through a system call. So this system call is really important here. So the protection or preventing of execution of these privilege instruction, or which are not allowed for that user in the user mode, is the IO protection. So we want to make sure that user can't execute any execution he wants, right? So it always have to go into the kernel mode. So that was it for this lecture, and I will see you in the third lecture of OS series. Thanks for watching.